Okay guys, pit stop A has two sets of notes. Notice 1 of 2, 2 of 2. We've made sure we labeled them stop 2, pit stop A notes. This one says the exact same thing. Alright, so I'm going to start on arithmetic and geometric sequences. Notes 1 of 2, so I'm going to set this one off to the side and we'll come back to it. So if I open these up to get started, sequences. That word is sequences. Okay, so a sequence is a list of numbers in a specific order. Each number in the list is called a term. Okay, these vocab words are very important. So a sequence is a list of numbers in a specific order. Each number in the list is called a term. So we've got two types of sequences, arithmetic and geometric. We're going to start with arithmetic. Arithmetic can be found by adding the same number to the previous term. Well, what do you notice about arithmetic and adding? They both start with an A. So that's how I remember arithmetic and adding. So if I'm adding the same number each time in my sequence, adding, arithmetic, both start with A. Okay, so knowing that, let's describe the relationship between the terms in the following sequence. Well, 4, 8, 12, 16. What are you doing each time? Well, to get from 4 to 8, I added 4. To get from 8 to 12, I added 4. To get from 12 to 16, I added 4. So what am I doing each time? I'm adding 4. Okay, adding, arithmetic, both start with A. Knowing that I need to add 4 to get the next number, what are the next 3 terms in the sequence? So they want us to find the next 3 numbers. Well, here's 16, and if my pattern is to add 4, well, 16 plus 4 would be 20. And then 20 plus 4 would be 24. And then 24 plus 4 would be 28. So that's an example of an arithmetic sequence. Okay? A geometric sequence, that's the other one. That can be found by multiplying the previous term by the same number. So arithmetic is adding, geometric is multiplying. Remember, arithmetic and adding both start with A. Geometric sequences can be found by multiplying the previous term by the same number. So for instance, let's look at this sequence. Well, how do I get from 3 to 6? Well, you may say add 3. But is 6 plus 3 12? Is 12 plus 3 24? No. So I can't be adding 3. So what's another way to get from 3 to 6? Well, I know 3 times 2 is 6. Is 6 times 2 12? Oh, yeah. Okay, so maybe times 2 times 2 is 12 times 2, 24. It sure is. So what am I doing each time? I am multiplying by 2. Okay, so I'm multiplying by 2 each time. How do I get the next number in my sequence? Well, I multiplied the previous one by 2. So what are the next 3 terms in the sequence? Well, I need to know 24 times 2, and 24 times 2 is 48. And then to get the next number, I would multiply 48 times 2. So 48 times 2, 2 times 8 is 16. That would be 9. So 96 is my next number. And then to get the next number again in my sequence, I would multiply 96 times 2. 2 times 6 is 12. That's 18 plus 1 is 19. So 192. So the next 3 terms in my sequence would be 48, 96, and 192. So again, arithmetic and is adding each time. They both start with A. Geometric is multiplying, okay? So let's go down here. Determine whether the following sequences are arithmetic or geometric. Remember, arithmetic and adding both start with A. Geometric is multiplying. So let's look. 2, 4, 6, 8. Well, I know 2 plus 2 is 4. 4 plus 2 is 6. And 6 plus 2 is 8. So each time I'm adding 2. So this, because it's adding, is arithmetic. Okay, let's look at this one. 4, 12, 36, 108. Well, I know 4 plus 8 is 12, but 12 plus 8 is not 36. So I know I'm not adding 8. So what's another way to get from 4 to 12? Well, 4 times 3 is 12. Is 12 times 3 36? Yep. Is 36 times 3 108? Yep. So since I'm multiplying each time, this would be geometric. Okay, so remember when you're labeling arithmetic or geometric sequences, a sequence is just a list of numbers. Okay, once you put it into a table like this, it's no longer a list. Now it's in a table. So you can't do arithmetic or geometric. It's only arithmetic or geometric sequences, and a sequence is a list of numbers. Okay? So this says, let's put the above arithmetic sequence, so that means I'm using this one right here, because this one's my arithmetic sequence. Draw an arrow. Into a table. The first number in the sequence will be the first term. Okay? Or for instance, first term, that's also the number 1 term. The second number in the sequence will be the second term, or number 2, and so on. The third term would be, or the third number in the sequence would be the third term, or number 3. Okay, we're going to put these numbers, those terms, first, second, third, we're going to put those in the input column. Okay, so let's take those. This is the first term, second term, third term, fourth term. So first, second, third, fourth. The numbers from the actual sequence will go in the output column. Okay, so the numbers from the actual sequence, these actual numbers are going to go in the output column. So 2, 4, 6, and 8. So the first term was 2, the second term was 4, the third term was 6, and the fourth term was 8. All right. The input, or X, is also called the position. The output, or Y, is also called the value of the term. So this is the position. This is called the value of the term. So at position 1, it has a value of 2. At position 2, it has a value of 4. Position 3 has a value of 6, and position 4 has a value of 8. Okay, so now let's find a rule that we can use to help us determine what the nth term will be. And remember, n is a letter or a variable. Okay, so n is a variable for a number that we don't know yet. All right, so it's just saying let's find a rule to help us figure out if I picked position 200 and this table went all the way down to 200, how would I figure out what the output is without having to do all that work in between? So we're going to figure out a rule. All right, so let's say, how do I get from 1 to 2? Well, I know I can do 1 plus 1 is 2. Let's see if that adding 1 works. Is 2 plus 1 4? No. 3 plus 1 is not 6. 4 plus 1 is not 8. So adding 1 does not work. What's another way to get from 1 to 2? Well, I know 1 times 2 is 2. Is 2 times 2 4? Yes. 3 times 2 is 6, and 4 times 2 is 8. So since that works for at least the first 4, guys, and I recommend that you don't just try it on the first and second one. You need to try that rule that you're coming up with on at least 3 or 4 of these to make sure that your rule works. So we're saying that this is 1 times, whatever your x is times 2. So remember, instead of writing our multiplication symbol or a dot, we just put the number next to the variable. So 2 times x. So this is saying take whatever you have for x and multiply it by 2. Okay, so 2 times 2 is 4. 3 times 2 is 6. 4 times 2 is 8. All right, if I had the 5th position, if I multiplied that by 2, I would get 10. So our rule is 2 times our x value. That's our rule. Now that you know what the rule is, let's use it to find the 50th term in the sequence. So if this went all the way down to 50, what would my output be? Okay, so remember, we write the rule so that I don't have to fill in all these numbers in between 6, 7, 8, 9, 10, all the way up to 50. I can just take 50 and plug it in for x. So 2 times 50, well, that equals 100. So the value of the 50th term would be 100. Okay, so this is the first set of notes. Now let's go to the second set. Okay, so arithmetic and geometric sequences in tables. Now we're going to put them in tables. So this is notes 2 of 2 for stop 2, pit stop A. So we're going to take what we just did on our last notes and we're going to apply that to different problems just to practice. Okay, so first and foremost, let's define whether this sequence, a list of numbers, is arithmetic or geometric. Okay, after we figure out if it's arithmetic or geometric, we'll take these, we'll plug it into a table, and we'll find a rule. So let's see, how do I get from 15 to 30? Well, I know I can multiply by 2, but 30 times 2 is not 45, so that doesn't work. So 15 plus 15 is 30. 30 plus 15 is 45. Oh, it looks like I'm adding each time, so this would be arithmetic. Okay, so now we're going to take this and we're going to plug it into the table. Well, remember, our inputs are our terms or our positions. So this is in the first position, second, third, fourth. Okay, so I'm going to take that in my input. I've got my first position, second, third, and fourth. Okay, in the first position, I get 15. Second position, I get 30. Third position, 45. Fourth position, 60. So now to write a rule, I got to figure out, what do I do to x to get y? What do I do to x to get y each time? What do I do to x to get y? What do I do to x to get y? That's a question you need to ask yourself. What do I do to x to get y? That's for when you write the rule. Okay, that's very important that you ask yourself that each time. What do you do to x to get y? Well, I know 1 plus 14 is 15, but 2 plus 14 is not 30. Okay, so that doesn't work. So what's another way? Well, 1 times 15 is 15. Is 2 times 15 30? Yes. Is 3 times 15 45? Yes. Is 4 times 15 60? Yes. So it looks like I'm multiplying by 15 each time. So my rule would be 15 times x. Okay, let's look at number 2. Let's not worry about labeling arithmetic or geometric because I can see how that may get you a little confused. So here's number 2. 7, 8, 9, 10. Well, again, position 1, 2, 3, 4. So here's my position. 1, 2, 3, 4. Let's throw a 5 in there. Okay. My first position is 7. Second position is 8. Third position is 9. Fourth position is 10. My fifth position would be 11. All right, so now we need to write a rule. So again, what do I do to x to get y? So here's x. What do I do to x to get y? Well, I know that 1 plus 6 is 7, so let's try that. Is 2 plus 6 8? Yes. Is 3 plus 6 9? Yes. So 1 plus x plus 6 plus 6. Is 4 plus 6 10? Yes. Is 5 plus 6 11? Yes. So each time I'm taking x and I'm adding 6. So my rule is x plus 6. X plus 6. You may be asking yourself, why did you put the number here if it's x times 15? Why didn't you write x and then 15? It's just a rule of thumb that we always write the number first. Okay, so that number you're multiplying by always goes to the left or in front of your variable. You wouldn't write x 15. That's just not the proper way to write it. That's the way we write it. Okay, so let's look down here. We're gonna, after we figure out what our rule is, we're gonna find the value of the 10th term. Okay, so let's figure out, what do I do to 1 to get 7? Again, that rule comes back to, what do I do to x to get y? What do I do to x to get y? So here's my x's. I know 1 plus 6 is 7, but 2 plus 6 is not 14. So adding 6 doesn't work. 1 times 7 is 7. Is 2 times 7 14? Yeah. 3 times 7 21? Yeah. Okay, so I know I'm multiplying by 7 times 7 times 7 times 7. So I'm taking my n, or my x, and I'm multiplying it by 7. So my rule is 7 times n. Okay, and if I wanted to know the 10th term, well, I know I'm going to multiply that times 7. So 10 times 7 is 70. Okay, I'm going to add 10 down here so we don't forget about it. Okay, let's look at the last one on this page. Here's my inputs, my x's. Here's my outputs, my y's. So what do I do to x to get y? Again, back to that rule question. What do I do to x to get y? Do you see how we refer to that all the time? So what do you do to x to get y? Well, 1 plus 10 is 11. Is 2 plus 10 12? Yes, so far so good. Is 3 plus 10 13? Yeah. Is 4 plus 10 14? Yeah. So it looks like I'm adding 10 each time. Plus 10. Plus 10. So my rule would be n, or x, excuse me, plus 10. X plus 10. I'm adding 10 to x to get y. So if I plug that in here, 10 plus 10, well, 10 plus 10 is 20. So my 10th term would be 20. So remember, when you're writing your rule, what do you do to x to get y? What do you do to x to get y? Well, I add 10 to x to get y. And then to know the 10th term, well, 10 plus 10 is 20. That's all you do.